So next, try natin ang problem 627. So etong ating beam ay meron loading na combination of triangular load and rectangular load. So nakita tayo ng ganito, divide natin siya into two shapes. So etong total na to is a rectangular load, and eto naman sa taas, yan yung ating triangular load. So if ang height ng ating rectangle is 200 and ang total height nito is 600, then definitely ang height nito ay 400 Newton per meter. Then before tayo proceed is hanapin natin yung resultant nito. So para sa rectangular loading, ang kanyang resultant is determined using the formula base times height. Yung ating base, yan ay 3 plus 1, 4 meters times height na 200. So siya ay nakaposition around dito. So 200 times 4. Ngayon, paano natin nasabing dito ang kanyang position? Para sa centroid ng rectangle, ang formula is base over 2. So base natin is 4 divided by 2, yan ay 2. So 2 meters from this point and 2 meters from this point. And para naman sa triangular load, siya ay 2/3 from the lower edge ng ating triangle and 1/3 ng base nung mas mataas natin na edge ng triangle. So next part is to determine the values ng ating R1 and R2. So using ating equation summation of moment, to be specific, na pili ko is R2 is equal to 0 with the assumption na counterclockwise ay positive. So first force natin is R1, kanyang distance ay 3 plus 1, 4 meters. Rotation is clockwise, so negative. Negative R1 times 4. Next is etong 200 times 4. Rotation is counterclockwise, so positive. So ito pa rin yung force natin. And ang kanyang distance from R2, yan ay base over 2. Base natin is 4 divided by 2, simply 2. Then, para sa triangle naman natin, siya ay counterclockwise, positive siya. Yan ay 1/2. Ang kanyang base ay 3. Kanyang height ay 400. So this becomes 1/2, 3 times 400. Yan pa lang yung force natin, resultant force. And ang kanyang distance from this point is 1/3 ng ating base. Ang ating base ay 3. 1/3 ng 3 is simply 1. Transpose. Then eto, simplify natin. So eto ay 2,200 dividing both sides by 4, yan ay 550 newtons. Yan ang ating R1, 550 newtons. Then to determine R2, summation of forces acting around the y direction, R1 is 550. Ito is 200 times 4, negative 200 times 4 kasi pointing downwards. Ito naman ay negative 1/2, 3 times 400 kasi pointing downwards, and plus R2. Kapag na-simplify, yan R2 is equal to 850 newtons. So after ma-determine ang ating support reactions, proceed na tayo sa ating pag-graph. So pasiguro lang tayo ng extra moment diagram dito. So, okay. Pipili tayo ng ending point na kung saan yun yung ating moment center. So, for example, napili natin is ito. Ibig sabihin, lahat ng forces natin is imo-moment natin about this point. So, ibig sabihin, etong R2, wala na siyang moment dito kasi dumadaan siya dyan. So, R1. So, anyway, before tayo proceed, ito yung ating assumptions. For example, ito yung ating beam. And kunyari, ang napili nating moment center is etong nasa gitna. Lahat ng forces na nasa left ng ating moment center, ang ating assumption, clockwise is positive. Para naman sa nasa right, counterclockwise is positive. Kasi, para pa nagbento, siya ay smiley face. Kaya siya positive. Not all the time, pero ito yung ating gagamiting assumption. Positive kapag napoproduce natin is smiley face. Then, proceed tayo. So, ito yung napili natin na moment center. Ibig sabihin, lahat ng forces natin is nasa left side ng ating moment center. Ibig sabihin, ito yung ating assumption. Clockwise is positive. So, R1, kanyang rotation about dito, yan ay clockwise. So, yan ay positive. R1, which is 550 times the distance of 4. So, 550 times 4, yan ay 2,200. Then, ang guide natin, pag meron tayong concentrated load, ang kanyang graph ay triangle. Sa basahin ng guide natin, kapag meron tayong moment or couple, ang graph niya is rectangle. Pag meron tayong concentrated load, ang graph niya ay triangle. Kapag meron naman tayong rectangular load, ang graph niya ay second degree curve. At pag meron naman tayong triangular, yan ay third degree curve. So, ito ay triangle muna. Then, next force naman natin is etong rectangular load. 200 times 4 yung ating force. Kanyang distance ay kalahati ng base natin. So, yan ay 2. Times 4. 800 yung ating total force. Times a distance of 2. 1,600. Pero since ang kanyang rotation ay counterclockwise, siya ay negative. Negative 1,600. So, take note, ito ay isang rectangular load. So, meaning, ang kanyang graph ay second degree curve. So, yan yung itsura ng graph niya. So, since yung ating load ay nag-extend from this point to this point, kahit yung graph natin, nag-extend din siya from this point to this point. Okay? Next naman is yung ating triangular load. So, ang kanyang span is from this point up to this point. So, expect natin na yung ating graph is nag-start dito. Okay? So, first, determine natin yung ating resultant force. Yan ay 1/2 times base, which is 3, times height na 400. So, yan ay 600. Then, ang kanyang distance from moment center natin is 1/3 ng ating base. Ang base natin is 3. 1/3 ng 3 is 1. So, siya ay 600. Ngayon, ang kanyang rotation is counterclockwise, contrary to our assumption na clockwise ang positive. So, meaning ito ay negative. Negative 600. So, graph natin. So, mag-ibag natin. Ito, triangle naman siya. Pero ito, since ito ay rectangular, ito ay second degree curve. Ito naman ay third degree curve since ito ay triangle. So far, ito pa lang naman is yung diagram natin. Ang pinaka-pinapredetermine sa atin dito sa moment diagram by parts is the value of area between A and B from the location na A. Location ng centroid natin is from point A. And meron din tayong pero this time from B. So, ang ating kukuning area dito is area based sa diagram natin. So, area naman ng triangle natin, 1/2 base times height. Ang base nito is 4 meters. Height nito is 2,200. So, ito ay 4,400. Positive 4,400 kasi nasa positive part siya. Copy lang natin dito. Then ito nasa negative part. So expect natin na ito ay negative. Ito nasa negative part. Ito ay also negative. So area nito, second degree curve. So siya ay 1/3 base times height. Ang base nito is 4. Kanyang height ay 1,600. So, ito ay set na natin as 6,400 over 3. Then, dito naman, siya ay third degree curve. So, pag third degree, hindi na siya 1/3. Siya ay 1/4 base times height naman. Second degree, 1/3 base times height. Third degree, 1/4 base times height. So, ito ay, ang base niya is 3. So, 1/4 times base na 3, times height na 600. So, ito ay 450. Then, okay. Next naman is take note na i-multiply natin dito sa area natin yung kanyang centroid from A. Then ito naman is centroid from point B. So for triangle, siya ay 1/3 from B and 2/3 from A. So ang total base natin is 4 meters. So from point A, yan ay 2/3 times 4. Then para naman sa point B, siya ay 1/3 ng 4. Then para naman sa ating second degree curve, kung dito ay 1/3 from the highest point, dito naman is 1/4 from the highest point. So ito ay 4 meters, so 1/4 ng 4. Ay baliktad. Ito yung 1/4 times 4. 1/4 ng 4, then definitely ito ay 3/4 ng 4. Wait lang, double check. Okay na yan. Then para naman sa ating 450, so ang formula naman centroid ng third degree spandrel, kung ito ay 1/4 from the highest point, ito naman ay 1/5 from the highest point. So total haba nito is 3 meters. So siya ay 1/5 from this point. So if ito ay 1/5, then definitely ito ay 4/5. 4/5 of 3 up to dito pa lang yan. Kasi need natin is from A. So, plus 1. Again, 4/5 ng 3 plus 1. Then, calculate natin. So, sa ating first part, nakuha natin ay 3,803.33 Newton meter cube. Para naman sa ating area, moment of the area from point B, yan ay, so dito, ang ating nakuha ay 3,463.33 Newton meter cube. So, ito na yung ating final answer. This is area moment by parts.